Welcome everyone. We are starting the third Polkadot Hungary Meetup. I really hope that the streaming is going well. I'm getting some feedback right now from the remote attendees. I have prepared some news for the start about Polkadot and what's going on in this world now. First of all, we have succeeded on Stack Exchange really quickly, like around in 2 months we had enough commitments to get accepted. Of course, it means if you have committed into helping in the community, then you need to do some posts and answer some questions there. But we were really quick on that, like 2 months is super quick compared to other cryptocurrency projects. Most of the time it takes like half a year. So this is really good success. And the other one showing us that we are reaching momentum to 10K on meetup.com, and that's a lot. And it shows again that our community is active, and I'm really happy that we also have gathered here. Even though we have this COVID situation, we have quite a few people attending the meetup locally and also through live stream. So we are already in 43 countries, and some of those countries actually are also working with us, because I just recently became Polkadot head ambassador of Eastern Europe. So I am connected now to Ukraine and also to Poland, and we are doing some collaboration right now. Other good news is that since the parachain system went live and we had the first auctions finished, everything is going really smoothly so far, and we can see that the projects are quite stable. There are no big hacks so far, even though there is always some hack appearing, but so far we are really good, and this shows again that things are going quite well. And yeah, another interesting news about Gavin Wood is he posted that he opens up the possibility to work personally with himself. So if you feel the power in yourself and that you have enough skills and knowledge to work with him on research projects, then you can contact him. And he posted it a couple of days ago on Twitter, and it's still open. You can message him personally through his email address, and yeah, good luck if you do that. But if you are not prepared, you can also learn about Polkadot, smart contract, and programming if you join our Telegram group or our learning workshop group, because with a few people who are also there, we decided to start just in really small group, but to learn first of all Solidity and how to use Solidity on Substrate based, and then on the long run we plan to move to Rust and to code smart contracts in Rust. So if you want to do that, or if you are not yet in the Telegram group and want to get the news and what's going on here in Hungary, then here is the QR code and you can join. So this was the short news on what's going on right now. And the next presentation will be a presenter from Parity. He is called Sacha, and he will speak about decentralization and how to develop and make projects that are more decentralized. I leave him his own introduction. It will be in his stream, so let me connect to him, and thank you for listening to the news.
Today, at least virtually, this is a pre-recorded video, and we do these things to avoid technical difficulties, so hopefully there won't be any technical difficulty. However, I will be here via video during the session after this presentation. So Huge thank you to the organizers of this event. It's super great to have like these kinds of meetups and bring people together that are excited about the Polkadot ecosystem and building Substrate. So real quick, who am I? I'm a developer advocate at Parity Technologies. So my job really is just to sort of advocate about all of these cool things that we are building in this ecosystem. And currently I'm working on a lot of technical writing with regards to the sort of general developer hub that exposes like all of these libraries to build substrate-based blockchains. What is Parity real quick? Well, for those that don't know what Parity is, it's sort of the main engineering force spearheading the implementation of the Polkadot protocol. And with that, building libraries to be able to build these types of blockchains and blockchains that connect to Polkadot-like blockchains, which is really what Substrate is as a whole. So before I just dive right in, there are QR codes throughout this presentation. So, maybe get your phones out, install the QR code app if you don't have it or whatever, but I did put some links that you can kind of just quickly scan and then have it right on your phone or whatever, port it over to your computer after. Could be handy as we're going through things. So what's the overview for today? Well, I chose this topic really because sort of like the big picture here is we're talking about governance. But first of all, I can't assume that everyone in the audience is familiar with Substrate, and so I want to kind of just start with like what is Substrate and how can we kind of just get going to build with it, right? And then we're going to go more into the nitty gritty. And by the way, this is the first time I'm doing this presentation. I've been very passionate about building systems that really care about the governance that's at play and sort of systems that are optimizing and making the best use of these tools that Substrate provides. And mainly because I think that Substrate allows us to really build really unique things that other types of applications on decentralized technologies don't really have. So what and why governance? Why do we care about governance, right? Then I've broken things down to go into sort of the mechanisms that we can identify when we're building these systems to kind of extract these types of mechanisms and see where they've already been implemented, maybe to be able to use them in your own applications. So that kind of tricks to this fourth point here that I'm hoping to go into, which is like these primitives. What is an example of putting these primitives together to create a sort of overall mechanism that we can kind of call a thing that is used for governance in the systems that we're building. And then what could you build, right? So I want to kind of inspire you. What are the things that you could be solving for your specific applications? So this is not a presentation to teach you about what governance should be and what it really looks like, at the cutting edge of Substrate built systems. Not at all. It's really meant to inspire you to kind of shed light on different approaches that you could have when you're thinking about building applications on your blockchains, right? And so we will go into sort of what that kind of looks like, because we're talking about building applications on blockchains, but we're also talking about building blockchains. So that's something that that I'm hoping that we can together wrap our minds around. My goal, it's not necessarily to propose solutions, right? It's really just to equip you with these tools and the mindset that you would want to have when thinking about how to implement these solutions. So if you're new to Substrate, that's totally cool, right? Like this presentation really wants to step you guys through what Substrate is and how you could use it, whether you're a developer or not, right? I think that it's valuable for even non-developers to sort of understand at a high level how these mechanisms can be put into place, right? So if you're maybe someone prototyping or just kind of have a cool idea, right? Like, what is available for you, right? I think a lot of us might know people or also be these people that have really cool ideas, but oftentimes we just think that maybe it's not possible or whatever. What do I know? Like, I just need to like hire a developer and he'll figure it out. But so I want this presentation to be this high level thing so that all of us in the room can appreciate how to build with these components. And if you're a developer, part of this presentation is kind of just going to touch on a deeper level of what are these primitives, how could you identify them by making the most of Substrate and the libraries that it exposes. So more specifically, like if you guys, if there's developers here who are more seasoned with Substrate, this is kind of giving you guys a sort of a lead, or what's the word? It's kind of just shedding light on where I would go to get inspiration and to see what these mechanisms look like in the current libraries that Substrate provides. So, what is Substrate? Well, I looked through some past meetups with this community here, and I think there was already given a talk about what Substrate is. So I'm not going to ponder too much on it. However, Substrate is a flexible, extensible framework for building blockchains. It's important to understand that Substrate isn't it's not meant to be just a library to build applications on top of blockchains. No, it is really an it's a toolkit to build blockchains. And so that means that it has all of these kind of core capabilities out of the box. I think that these were also touched on the previous meetup. But however, I will go through. So basically, Substrate is modular. We don't need to build everything from scratch if we want to build application specific blockchains. With Substrate we have the consensus layer that's taken care of. We have a networking layer out of the box. We have a transaction pool out of the box, block execution. So that kind of really gives developers getting started a huge advantage because they don't need to implement these really complex things. It's worth saying, this is probably the point I should have started with this slide, is that Substrate came out of the development for Polkadot, right? So Polkadot had been sort of an idea that was developed, sort of that was elucidated in a white paper, and then from the white paper, there came a time where developers sat together in a room and started implementing it. And in doing so, they realized, oh, what if we could sort of abstract all these core things that we're building for Polkadot and create a standalone library that Polkadot will use, and we'll call that Substrate, right? So Substrate, then it becomes important to understand that it was built with the mindset or sort of the design decisions behind Substrate is that it's built to be used by all sorts of different applications. So it has to be modular, right? It has to be able to sort of enable maybe some mechanism that is better implemented in another library. Well, that mechanism can be easily kind of pluggable in a system built with Substrate. So this concept of using Substrate for this multi-chain future, right? So we don't know what these chains look like, but at least with Substrate, we can build. We have the toolkits to build very general purpose kind of libraries that then can extend capabilities that become more and more specific. So it has to be dynamic, right? So that this is a very key part of building blockchains with Substrate, as it enables forkless runtime upgradability, and that means that any chain does not need to sort of be forked to have like system level changes. And we will go into this with regards to governance. However, it's worth mentioning that, and it's adaptable, right? So that just means that we can adapt to change. For example, if the storage layer that the blockchain is using is maybe not suitable anymore, or it's not optimized for a specific use case, we can actually swap out that storage layer. So Substrate allows blockchain developers to build domain-specific chains. That means that these chains have very specific applications, and that blockchain is optimized for that application. And like I just mentioned, we don't need to rewrite all these complex modules, right? So within Substrate, we have this thing called Frame. Frame makes it very easy to compose the business application of your blockchain, right? So you can picture sort of like Substrate being this library that gives you the consensus layer out of the box. It gives you the transaction pool out of the box. Out of the box, basically, you can just get up and running without needing to rewrite complex implementations of these things. And once you have that, then what do you really want to do? Well, you want to write what makes your blockchain unique, right? This is what we call the application logic of your chain, and this all happens in the runtime of your blockchain. And so Frame is basically a library to write Substrate runtimes, and it's a library that makes it very easy to write Substrate runtimes. In theory, you could use or implement a whole other library that knows how to talk to these consensus layers and transaction pools and such, but that would be probably a lot of work to write. And currently Frame exists, and it's super powerful. So the concept of Frame really is you've got a way to build pallets, right? So a pallet is simply some application-specific logic that you want for your chain, and the sort of support libraries of Frame really comes down to, there's a system pallet that in of itself is a pallet that kind of enables these cross-cutting functions for your runtime to talk to other parts of the node. And then you've got the Frame support that is just support code for the runtime. So that's kind of like taking all these like Substrate primitives and all that this stuff and making it easy to be able to use and write application-specific logic. So yeah, this is just a screenshot of crates.io. Frame provides us with a way to simplify runtime development and to really like this is where this power of composability comes at play, right? Because every piece of logic can be its own palette. I mean, within reason, the design space is really kind of very open. So it allows you to make transactions. In a palette, we can handle events and errors and sort of interact with other palettes too. So at a high level, like this looks like, we have all these palettes that we put into the runtime, and our runtime is the state machine of our blockchain. And every single palette has a very specific role. So for instance, this is just some random palettes that for the sake of this demonstration, but the ones that are highlighted here really handle the consensus and kind of networking layer stuff of our blockchain. So that would be Aura. Aura is the proof of authority consensus protocol, and Grandpa is the finality mechanism that can finalize blocks. And there is also a timestamp palette. By the way, these palettes all exist, and the timestamp palette is specialized to provide a timestamp for the validators and the nodes, right? So basic like blockchain stuff. Then we can think about okay, well, what's going to handle the currency type things that are happening in our chain, right? So there's a balances palette for that, and Frame provides this balances palette out of the box, like to have some sort of common such that your runtime has a common understanding of balances throughout. And we can also think of, there's a treasury palette and a bounties palette, each of which are maybe, they communicate a lot with each other, but they are separate palettes because they carry separate kind of pieces of application logic. And then, this is kind of where what we're talking about today in terms of governance. We have palettes that are specialized to sort of the heavy lifting of governance mechanisms. Runtime. This would be, for instance, the Polkadot runtime has a democracy palette, it has a collective palette, and the society palette actually is, I think, only in the Kusama runtime. I haven't verified, but I think that this is true. And the society palette basically is specialized to create memberships and kind of communities that have maybe special privileges over a spend in the treasury, for example. So the big picture here is, composability. Now, if you scan this QR code, you will actually get to the code snippet that we're looking at. And this code snippet is really kind of exemplifies what we went over, but as it is sort of implemented in Substrate or in a Substrate node. So this is the construct runtime macro. That's just a kind of for non-programmers, that's just a heavy loaded term for it's where this where all of these palettes, all of this logic sort of that is modular. I mean, we each have we have a balances palette, we have a transaction payment palette, we have a pseudo palette. Well, it's where the runtime puts it all together. And so for instance, again, this is actually the node template that we use when folks are getting started with Substrate. You can see the consensus stuff is there, the currency stuff is there, and the governance stuff is there too. The pseudo palette is a very primitive type of governance, really. So, what is governance and why bother? There's a lot of like good material out there that talks about what governance is for Polkadot and sort of this concept of a meta protocol. I'm sure at least some of you in the room have heard this term. Really, Gavin makes a lot of Gavin has a lot of good sort of descriptions as to what he means by meta protocol. But essentially, it's this concept that we have a system that has a bunch of rules defined in it, but we need to have rules defined that can control how those rules are defined in that system. That sounds maybe very confusing. However, we will kind of dive a little deeper into that in the next slide. But at a very high level, at this kind of base layer of, let's all be on the same page of what we mean when we talk about governance. Governance is a system of rules to make decisions with participants being held accountable. And really what that kind of alludes to is, stakeholders need to be able to come together and make decisions on a common set of rules. The importance of governance, why bother really, right? Well, the importance of governance is because we need systems that can sort of encourage innovation. We want our systems that we build, these unstoppable blockchains, they have to have a way that encourages and embraces innovation. And that really then kind of comes to this adaptability side, where we need to be able to adapt to change. It's, what's the use of having a blockchain that has a bunch of really great innovations but can't really adapt? And evolution is also kind of key in all of this, where the evolution of a system has to be taken into account, because maybe some rules that were defined previously don't reflect the sort of new real world scenarios that we're faced with, and so we need to be able to evolve. So meta protocols ensures long-term viability of the systems we built. So this kind of meta protocol concept and what we mean by governance from a Polkadot perspective, it's really that we have these rules over a system, and we need to have a way that we can use these rules that are over a system to sort of control or enable these notions for innovation, evolution, and adaptability that are most likely defined as the rules within the system. So, for example, the rules that define how to change the inflation rate of a system is sort of this governance meta protocol type rule, whereas the rules on the conditions for a slashing event and like these parameters that are maybe more on the staking side of the system, these are rules within the system. Another example that actually Gavin gives is sort of the parliament versus civic laws, right? So the parliament and sort of the government that is of a country is what we talk about as like rules over a system, whereas the civic laws, the actual laws that can change depending on who is in power, these civic laws kind of correspond to the rules within the system. And so kind of these notions are important to just grasp with regards to the importance of kind of just being familiar with these types of terminologies is just for the sake of when we're building these blockchains that are really layer 1 chains or layer 0 for some, this kind of balancing act between thinking about governance at that level, but then there's also sort of other types of governance that we will go over that could also be considered governance, but maybe not by this definition. However, the way that I want to present things today is really kind of thinking of these as sort of two separate things. So, for example, in Polkadot, we have a system whereby communities members can make proposals, and councillors can vote on these proposals, and committees are used to appoint different council members through democracy, which we have a pallet for, and certain then motions that get passed to referenda and voted by the community with dots and stake weighted voting, and then a proposal will get enacted or not based on some sort of conditions, right? And so within this picture of governance, we think of we can kind of break things down to like these mechanisms that enable, whether it is sort of this meta system over the system or more granular sort of like some treasury spend that has been enacted from something that's perfectly kind of legal in regards to a valid proposal that is made by a community member. However, these mechanisms in place kind of are this like broken down version of governance, in my view. So when I talk about mechanisms, I mean mechanisms that enable stakeholders of these systems to collectively determine the optimal outcomes for that system. So really what this means is that these mechanisms are ways that, as developers, we can programmatically interact with the systems of governance in place. For instance, in Polkadot, we're never going to change with a single sort of call that that governance and all the council members are no longer valid. We these are things that we can't change. However, what we could change is the appointed membership of some account that wants to join the society as implemented in Kusama, for example. So, but what's important for us today, right? By the way, this kind of these blocks of proposal, public referenda, enactment period, and past kind of just exemplify this process where at every step there's different mechanisms to enable that process and determine what these optimal outcomes are based on what is defined within the rules of these mechanisms. But what's important for us today is just to think about, what are the optimal outcomes of the systems that we want to build? Because they're not necessarily all the same, right? The other question we should ask ourselves is, who are these stakeholders? Are they just validators? Are they users that potentially maybe could maybe we're just talking about a DAO, for example, like a decentralized or autonomous organization where a bunch of users have a stake in a certain membership, and this membership entails doing such and such thing, and if these things aren't done, then those members get slashed, for instance. Within that scenario, those are arguably stakeholders in the system. And really, yeah, the important question here is, what is the system we're talking about targeting? What is the optimal outcome for that system? So the way that I've been kind of thinking about this, and this is not sort of by any means like correct. Or meant to be a guiding light that is sort of vetted or in any shape or form. This is really just how I want to invite you guys to think about what these different mechanisms are and their applications, right? So like what they're targeting. And the way that I think about it is that we really have this kind of spectrum of layers, whereby at the core layer we've got heavy lifting, consensus, staking, sort of software parameters that determine the validity of the parameters that really do the heavy lifting for the system to work, right? And so at that end, we talk about access control and really decentralization as a security model. If that decentralization as a security model breaks, then the system is likely to break. This is like not necessarily the stuff that I'm really like going to talk about in the next few slides. This is more sort of equally important for governance, however, more of a given out of the box when we build with Substrate, because these are kind of already taken care of, whether it's staking mechanisms and consensus algorithms that are already implemented. On the other side of the spectrum, we have the application layers, right? So we're building. So with Substrate, the whole thing is that we're building application-specific blockchains. And with governance, we can really be targeting so many different layers within that the blockchain. However, at the very end, sort of at the very top outmost layer, we have users interacting with our blockchain to meet their needs by using the application that we're building, right? So like application as in like, some useful thing that a user would want to be using the application for. And so this means, essentially, user interactions, but also cross-chain interactions, right? And it also could mean like mechanisms for recovering an account if it's lost. There's actually a recovery pallet. It's called the social recovery pallet in Substrate, for example, that does this type of heavy lifting, you could say, also, but for this type of mechanism. So with that kind of mental model in mind, and sort of really kind of honing in on more of the user interactions and applications side of things, right? Well, what's the design space we're looking at? Well, this is just a list of things that came to mind when I was trying to kind of present this information for you guys, where the purpose of this slide is really to it's really to kind of give you an idea of the different types of things that you could be targeting, sort of, or the different mechanisms that you may or may not be interested in when you're thinking about governance for a blockchain or governance for your solution, right? So really what it boils down to is there's on-chain stuff and there's off-chain stuff. And the on-chain stuff, we're most likely talking about a voting system of sorts, whether that's bonding or staking some DOT for a decision to be enacted or not. That's where conviction voting comes into. So, conviction being the longer that I'm willing to stake my DOT or my whatever coin, well, the more conviction I have to that to that proposal being made or whatever it is, which kind of gives me a heavier weight in the voting system. So delegation is kind of another one of those, again, a mechanism to sort of delegate votes to someone else, to some other account that is trusted or preferred. And then we can think of again, within the on-chain world, rewarding mechanisms. So basically slashing and rewarding, right? So, good behavior, bad behavior, we kind of reward, we reward correspondingly. So then on the right there, we've got kind of off-chain stuff. So that's really equally important. In the research I did to prepare for this presentation, I was looking at sort of where things are lacking with designing blockchains with good governance, and an important part is user experience. It sounds crazy, but there is not really good user experience in many implementations. I mean, with regards to making it easy to participate in governance, or making it easy to see what's happening so that we can then have informed discussions about governance, etc. And so essentially the off-chain stuff really talks about oracles, having really good trusted oracle systems. And when I say trusted, it just means finding ways to have maybe a mixed net or some sort of decentralized oracle system that takes data from many different sources, aggregates it, and then sort of finds some sort of truth for that data. Then also, in off-chain worlds, we think about signaling. That's such an important part, right? Nowadays, with DAOs and stuff, there's a lot of discussions that happen on Discord, and that's really important. So that's also something to think about. How do we kind of bridge that gap from off-chain worlds to on-chain worlds? And the other bullet point here is really just to talk about the types of nodes that we're building. This is more for developers who are thinking about bringing sort of user experience on the level of the types of nodes that they're interacting with. And so that kind of falls into the place of like, if you're building a block explorer, you want to have an archive node. Well, how can you make sure that your users trust that the node is, providing the right information and things like this? And the light client point there is really just to kind of shed light on the opportunity for building applications with light clients that are sort of by design in them, and what that could entail is some super interesting sort of like trust-free mechanisms for connecting directly to a blockchain. For those that are interested, I invite you to read up on Substrate Connect, which has been presented at the last Sub-Zero conference, and it's super interesting. Sort of, again in this design space of like trying to create less trust and sort of trying to encourage mechanisms that inspire trust within the users using them. So this kind of like boils down to this mental model that I have, which is there's the off-chain stuff and the on-chain stuff, and really at the core, there's on the on-chain stuff, there's a runtime that exposes all these pallets and the logic that they're exposing, and then the UI and the way that users can interact with that runtime, and then equally as important, there's off-chain stuff happening where people need to understand what maybe some proposal got enacted at the runtime level. Well, they should be made aware of it, because then they will have the sort of an informed opinion on some next proposal to be made. And I'm just kind of trying to use a very generic example, but this could apply to a runtime upgrade, or it could apply to some project that wants to add a new pallet and that wants to make a government proposal for it. Well, there needs to be maybe an off-chain discussion for it. But again, this can translate to something even more specific. The cool thing with Substrate is that these mechanisms can be split into their own pallets. So this is kind of what I want to talk about with regards to developers maybe interested in like building these systems, what they can use that's already created, and also maybe sort of pick pieces out that have already been implemented. So the Polkadot runtime is made of a bunch of pallets, like I kind of talked about briefly in the beginning here. Well, really, like what's cool is that you can see that some of these pallets are made for governance, like the council, the crowd law, the democracy pallet, and the election provider also has these kind of mechanisms put in place. So the first thing would be like, let's check these pallets out. We're not going to do that today, but I really I really advise you guys after this talk, to go into these code bases and look at what these pallets are doing and how they are actually implemented, and the parameters that they are using for the blockchains that they're used in. So if you use that if you go to that QR code, you'll just be able to like go to this subscan link and query these pallets, and then if for those interested, just look up the name of the pallet frame, and then you'll find it. So the frame mindset. This is like when we're talking about composing these systems with Substrate. Well, it's really about reusing elements that exist in pallets, identifying those mechanisms, and creating these sort of the requirements for that specific chain. The fortunate thing is that a lot of these mechanisms are useful in many different sort of applications, but also kind of like by tweaking these mechanisms can be more useful in one application, and provide functionality that then can be pieced together with some other mechanisms that exist to build out what the requirements that palette wants to meet. So this kind of reuse, create, refactor, and repeat. This is like what I super encourage you developers to think about, because with Substrate you really can do that, right? So like, for example, the bounties palette has been refactored I think in December at some point, not long ago, where the logic for creating bounties from so the logic for creating sub bounties basically was put into its own palette. So that means that for example, when you create a bounty, well, you might have follow-ups. So a big bounty, might have different milestones that it needs to accomplish, and then those follow-ups really could become sub bounties. So it became sort of more useful to have that logic as its own palette, because probably it makes it sort of easier to interact with other palettes, and also the child bounties have their own storage items and kind of can be treated as its own thing. And given that it kind of very strongly interacts with the treasury, it made more sense. So basically refactoring that logic into another palette, if it makes sense with regards to the storage items and stuff, I mean, that is like strongly kind of like best practice in a way, because at the end of the day, like, we want also people to use as many different palettes as possible, and kind of really making use of this modularity goes a long way. So these primitives, what they look like ultimately is, and when I say primitives, I'm talking about specific, like, in order to build these mechanisms we talked about, and mechanisms being like, for example, voting. Well, we kind of can break down like primitives to be able to create a voting mechanism, right? So, for example, going through the example of voting, we have conviction, we have delegation, we have locks. Like the currency trait in Frame provides a way to lock funds. Arguably, this is a primitive that we can use to build this type of voting mechanism. And then, simple majority votes being, an implementation that would enable just a certain threshold being met, like that. So, other mechanisms exist here that I've put. For example, participation. How do we have fair representation in our blockchain, right? So, it's not sufficient to say, one, anyone can vote with as many coins as possible. That would create unfair participation. Things like whales, etc. And so, implementing quadratic voting, for example, or a system that really pushes sort of the limits of like the ways that an account is being rewarded. We can kind of nest this logic and think about kind of breaking up these mechanisms into different primitives. The enactment is for an example of like, the enactment of a proposal. Once a proposal is supposed to be enacted, we're using primitives such as the block time. Literally, we need to use a timestamp to be able to know when that enactment period is ended. And origins. Origins is something I wanted to go a bit into detail, but maybe we'll kind of skip over it. But essentially, it allows sort of a palette to verify that the caller of a transaction is valid by some custom logic. So yeah, like, the origin system is a very important primitive. The origin system in Frame enables us to do checks on what types of accounts are allowed to do what types of things, very kind of broadly speaking. But typically, you will always find that before a function's logic is can be called, basically, you will see an ensure origin. And there's also ensure root, which means that, for example, blockchains with the pseudo palette can call any function that has ensure root. However, any other account is not able to call that. But then with origins, we can get more creative. This is where it becomes like really cool, because an origin is this primitive in Substrate that can be programmed as as understanding accounts, sort of root origins and different signed accounts or accounts that sign transactions and accounts that don't. But it can also understand and validate the source of a valid call or caller as a pallet itself, or a function from another pallet, or some sort of majority vote from the democracy pallet can only then be call a function, right? So really quickly, so this is an example in the treasury pallet. We define that the origin must come from this approve origin, and that just defines some sort of like check where it can either be the root. So if you're using sudo, you could just call this with the root, but then it'll have to be from the collective palette. So the collective palette handling all of the sort of managing who's in the council at that given time, and what other collectives exist. So for example, this is the council collective, you can see, and this stipulates that for this origin to pass, 3 out of 5 members of that council collective need to vote yes. So, and then this is implemented in the runtime by just passing that origin like you would do for any other origin. Then this is inside of the palette itself. Then if you just look at the bottom of this slide, it says approve origin, ensure origin. Well, essentially that line ensures that this call, this approve proposal call, can only be called if this is satisfied. So that if actually on chain in the state of that runtime, there is a majority vote for approving this proposal. And we're not going into sort of the details of this, but this is just to show that the origin primitive is super powerful when building systems with governance in mind, and composing these systems of governance. So this, just to kind of go over, like, where can you look immediately, like right now, like if you go to the collective palette, like you can see a proposed method that has been implemented. Same with all these other palettes that are listed on this slide. And really, it's just like there's a lot that is out there already. So I invite you to check it out, right? Are you interested in looking how delegation happens in the democracy palette? Well, it's right there. So there's a delegate function that enables an account to basically choose some other account to delegate on their behalf, to delegate votes on their behalf. And same with voting. There's lots of different types of implementations for voting, and the collective palette has some of the sort of more heavy lifting voting mechanisms, and the society palette has a really neat voting implementation too. So kind of wrapping up here, like, what's this landscape? This is, we're talking about a lot of things. And when I started doing this presentation, I realized that it can't just be high level without being, initially I wanted to really kind of go into implementations and stuff, but I think it's important to just be familiar with this landscape. We're talking about very complex things. We're talking about crypto economics. We're talking about user experience. We haven't even really talked about the fact that we can implement these systems. We before putting them into a production network, is there any simulation mechanisms that exist, or sort of simulation platforms, to simulate that crypto economic system? We're talking about game theory. A lot of the work that has been put into Polkadot and into the mechanisms that are implemented in Polkadot, including the current voting mechanisms and the staking and the democracy palette and how conviction works and all of these stuff. These are very complex things. This is the result of years of research and collaboration of really well-versed people in the field to understand the optimal outcomes of these systems. Again, this is very applicable to sort of any application here, right? Where we need to understand what those optimal outcomes are in order to build the right systems and mechanisms for them. And so with Polkadot, we've optimized, or at least what has been implemented has been optimized for the specific use case of Polkadot, which is, a security layer for other parachains. However, that's not the case for all blockchains building with Substrate that could be parachain on Polkadot. These blockchains, contrary to Polkadot, have their own needs and requirements. So what are the problems that you could solve? This is just, kind of to give inspiration to you guys. And as I was researching, I kind of came up with, this list. It's definitely not finite. It's just really, hey guys, this would be a cool thing to think about. So fragmentation. We're talking about a multi-chain future, right? So we're talking about this future where there's a lot of different chains. Well, what if we the problem there is that communities will maybe feel left out or siloed from one another, and how do we kind of mitigate against that? So what about multi-asset stake weighted voting? I think this has been implemented with projects like Akala, but it's something that is an important consideration to make sure that there's maximum participation, and that leads to the next point, right? So how do we make really how do we foster community outside of the on-chain world? Right now, there's a lot of activity right now there's a lot of on-chain governance stuff that kind of leaves out a lot of people just because they are too scared to maybe set up a wallet and they don't know, or whatever, it's intimidating. So let's think about how to solve these problems. Let's think about maybe creating, for example, there's a tip bot that we use within Parity Tech's organization for contributors that are putting a good PR together and that execute on it. Well, there's a GitHub Actions tip bot that just directly tips that address, and that kind of creates this sort of engagement from the off-chain into the on-chain world. How do we mitigate against collusion, right? So things like whale accounts and having off-chain verification mechanisms so that I can't just create a bunch of accounts and vote for the same thing. That would be really bad, right? So if you have a vote that goes up and all of the votes are really me, but on chain it just looks like a bunch of different people voted for it, well, this is a problem. And then we can solving problems with kind of common good funding. That's, I think, a huge topic where how can we have projects that get funded with sort of fair equity for the funders, and also backing by community members that really care about the project. The Polkadot Incentive Prize Program. This is just a way for me to kind of show you guys that this is real stuff, right? Like this happens on chain, and off chain. So this is an example of a proposal that was made by Parity that is talking about a pretty large sum of the treasury to be used to implement kind of core protocol stuff. I think that there's talks about ZK snarks and sort of on the level of we want to use this governance mechanism that Polkadot has to better Polkadot, which again falls into this kind of super important part of this presentation. Is like the systems that are in place for Polkadot are for Polkadot's needs and for optimizing Polkadot as a blockchain and protocol. And so this is an example of let's propose some spend to meet that and to address and take care of Polkadot and to meet the optimal outcomes of it. Some related resources here. I'll share the slides with David at the end, so you guys can check it out. And some developer resources. So how can you get started? The easiest way is to go on our developer hub and kind of poke around. You'll see that there's some tutorials there. You will also be able to learn from some guides to how to do things. But if you're a developer who's already kind of well versed with Substrate, I strongly advise you to basically clone Substrate, have it locally, and look things up as you're kind of trying to develop and pinpoint different mechanisms that haven't already implemented. Just search the name of that function, or search something that might come up that might be the same type of functionality and mechanism you're looking for, and look how it's done, right? Look how it's implemented in Substrate, because that is probably the best source of truth and source of in terms of the a good implementation of that thing is probably going to be in Substrate. And then also same thing with other chains such as Polkadot. I'm seeing their implementations. So with that being said, thank you so much. I hope that this was informative. I hope that it was inspiring. And really, I hope that some of you in the crowd that have ideas now are better equipped with thinking about how to solve certain problems. Some of you are already developing with Substrate, and hopefully really appreciate the importance of really building your systems with governance in mind, and how Substrate makes it really easy for you to do that. So if there's any questions, I'll be around after. And yeah, thank you so much.
Bullshit. My duty today is to introduce you to smart contracts. And in fact, smart contracts are amazing. You can do a lot of stuff with them. You can do banking, also called DeFi. Work together on projects via Gitcoin, for example. Also, a very warm welcome from my side. For those who don't know me yet, my name is Sebastian Kraus. I'm the co-founder of QRUCICAL, and we stand for blockchain security without the bullshit. My duty today is to introduce you to smart contracts. And in fact, smart contracts are amazing. You can do a lot of stuff with them. You can do banking, also called DeFi. You can work together on projects via Gitcoin, for example, or you can do some advertisement through basic attention token. But with that amazingness comes also a dark side. And the dark side, in fact, is that smart contracts are also amazingly dangerous. In fact, they are a little bit like the box of Pandora. Once they're out there and deployed, you can't get them back and put them back in the box. So if you made some mistakes in your code, you can't undo them. Many of you may ask themselves, yes, but aren't there forks or upgrades? And yes, that's all true. If you build you can fork a project. If you build a project through Substrate, you can also upgrade it. But the issue is that this is a race against time, because either we find the mistakes or the bad guys do. And if they do, they for sure won't wait to exploit them. In fact, smart contract hacks aren't going away. Just recently, there was the BadgerDAO hack, in which BadgerDAO was exploited for 120 million. We also had in the past some big hacks, like the Ethereum Parity multi-sig hack. And also, in fact, one of the biggest hack I'm gonna introduce you today, which was called the DAO hack. To understand the DAO hack a little bit better, you have to understand Solidity, and in fact a core concept of it. And that concept is called re-entrancy. This, for example, is a code vulnerable to the re-entrancy exploit. In fact, to understand why this code is exploitable, you have to understand that Solidity is very dependent on its order. For example, in line 7, we have the piece of code where the money is sent. And in line 8, we have the accounting part of it. And if you manage to exploit line 7, then you can get all this money out, because the accounting part comes after it. And in fact, if you think about how to fix this, it's amazingly and honestly mind-blowing how easy it would have been to save this project from disaster. All you would do is switch line and 8. If we look closely in this example, we can see the lines are just switched. This would have protected the DAO from being exploited. For sure, the DAO exploit was one of the biggest, and there isn't one person sitting on the computer and manually exploiting this vulnerable contract, getting the money out piece by piece. But the malicious actors are in fact smart and fast, so they write exploits which are smart contracts, and they use a smart contract to exploit another smart contract. This is an example of how this could look. For example, in line 1, we import the vulnerable contract. Then we have the function steal, which steals some tokens from this contract. And then we repeat. And what's also very important, in this code, we need to set a count, and we need to do our due diligence as an attacker and check out how much is there in a wallet, because if we over exaggerate this code, we would in fact send all the money we have gained back to the one who originally owned it. So this is not what an attacker would like to happen. So attackers are also setting the count in which they set how much, like how often this code is repeated. For example, in this case, we would get out exactly 1,000 Ethereum because this code would run 1,000 times. So malicious actors do the homework. So do we. And the count, for example, is there to not let the contract exhaust itself and send the money back, as I told you. And for sure, in the DAO hack and in all other hacks which are happening, these malicious actors, they do their homework. But with all that talk about the power of smart contracts, we also have to look at the dark side. And that is in fact that the power of smart contract can be used against Ethereum virtual machine itself, and then have a project vulnerable even if it was not intended to be vulnerable. So please be aware, with a lot of power comes a lot of responsibility. And please build your projects with security in mind, and in fact let them be checked by a second party, because it doesn't matter how good of a coder you are. You are also sometimes tired. You also have some issues in life or whatever. You may want to finish a project fast, but this urge can lead to issues like this, which are fully preventable. And this must not happen again. So please be aware, with power comes responsibility, not just for yourself, but also for your community and for the people who need your code for their project to run. And they depend on you, and we must not let them down. So now let me introduce you to 6, and let's hack some projects together.
To the live stream. So